Okay, acids and bases, notes number 2. Definitions of acids and bases. We're going to look at two different definitions. The first one is Arrhenius and the second one is Bronsted-Lowry. The first definition, Arrhenius acids or Arrhenius acids or bases, the definition focuses on the ions that are produced when the compound is in solution, or when it dissociates or ionizes. Okay, so acids ionize to produce hydrogen ions, in an aqueous solution. An example is going to be hydrochloric acid that's aqueous. It will dissociate into H pluses plus Cl minuses. Okay, but where nitric acid would be H pluses and NO3s. Now bases ionize to produce hydroxide ions. So hydroxide ions in an aqueous solution. Example will be lithium hydroxide that's aqueous, and it breaks up into Li pluses plus OH minuses. So our acid produces hydrogen ions, and our base ionizes to produce hydroxide ions. So the Bronsted-Lowry definition focuses on whether it can donate or accept a proton. Acids donate. I draw an arrow to remind myself that acids get rid of or donate a proton. So these guys are called proton donors. So they're going to get rid of one hydrogen. It gives it away. Whereas the base, this is going to be a proton acceptor. It receives that hydrogen. So the acid donates and the base accepts. All Arrhenius acids or bases would be classified as Bronsted-Lowry. But the reciprocal is not true. All Bronsted-Lowrys are not Arrhenius acids and bases. Acids and bases for Bronsted-Lowry are identified on the reactant side. What side is the reactant side? Good, that's the left side. And the conjugate acid or conjugate base is going to be on the product side, which is the right side. Okay. When acids donate a proton, so when they donate that proton, the resulting formula is called a conjugate base. So an acid forms a conjugate base. A base accepts a proton. The resulting formula will be a conjugate what? Good, acid. So yes, acids make conjugate bases, and a base will make a conjugate acid. All right, so identify it. So what we're going to do is we're going to put our finger here and here. We look at this ammonia. We look at this ammonia and we look at the ammonium, the matching formula. We say to ourselves, what happens here to make it look like this? What happened? What happened to this to make it look like this? It gained a hydrogen. So we're going to draw our arrow here because over here it gained one. So, or you can draw it here. We gain a hydrogen. Okay? So what is this called? If it accepts a hydrogen, it's a base because bases accept. So this is a base. So this will be my conjugate acid. What happens to water for it to look like a hydroxide? It lost one hydrogen. So we're going to draw an arrow here. So this will be my acid because it donates a hydrogen. And this will be my conjugate base, because now it's ready to receive a hydrogen. A conjugate acid-base pair are two substances related by the loss or gain of a proton. Okay. Another definition. All right, so let's look at the chart here. So acids, what do acids do? Gain or donate? They donate. So we're going to draw our arrow this way. Okay, to help us to remember to donate. The acids are going to lose one proton. All right, so what would its conjugate base look like? If we lose one proton, we lose one hydrogen, what do we have? HC2O4. And I had them equal positive, equal negative. I've taken away one proton, so what happens is the charge is -1. Good, -1. So the conjugate base is going to lose one charge. Okay, so let's look at the base. All right, so bases, what do bases do? They accept or receive the proton. So what would ammonia end up looking like? NH4. And what's the charge of NH4? Because we've gained one hydrogen? +1. Okay. And this is a -1 right here. It didn't print very good. Make sure you write that down so you can see it. So the bases gain one proton. So what does HSO4 -1 when it gains one proton look like? H2SO4. Good. And -1 +1. Hey guys, let's lift our heads up, please. So we're going to add one charge. Okay. Now we have one more definition here. A substance that can act as both an acid and a base is called amphoteric. Say that word with me, please. Amphoteric. This means it can donate or accept a proton. Water is a great example. So how is water an example? When it receives or accepts a proton, what would it look like? What is it? H3O. Great, a hydronium ion. Oops. And when it loses a hydrogen, when it acts as an acid, it looks like a hydroxide ion. Great. Okay. So let's look at these, the acids and bases. Which substances are amphoteric? Which one of these? Which one can donate a hydrogen and accept a hydrogen? Or HSO4 minus 1, because we're looking right here. Good. HSO4 minus 1. And what else? What has a negative charge and a hydrogen? HbO3 minus 2. So to be able to figure that out, you're going to ID amphoteric. You're going to look for a hydrogen and a negative sign. So to ID amphoteric, you're going to look for a hydrogen and a negative sign.